I'm Apurva Gaikwad and I will be talking about real-time upserts of data in Druid. I'm senior software engineer working for ThousandEyes data visualization team for past 3 years. As part of today's presentation, I will be starting with introduction to ThousandEyes to understand the problem ThousandEyes is solving. The second point, I will explain how Apache Druid is helping us with our use cases. After that, I will explain the problem and why we need to upsert data in Druid. In fourth point, I will go over workaround methods for upserting that we considered to support our use case. Next, I will cover the upserting mechanism that we came up with, which we call delayed enrichment. And as a last point, I will go over the limitations of this delayed enrichment method. Let's start with what ThousandEyes is. If I had to define in few words, I would say we are cloud intelligence company. We enable our customers to deliver superior digital experience. Some of our stats are displayed in the slide. We were founded in 2010, acquired by Cisco 10 years later, and we have some of the largest Fortune 500 companies as our customers. If you think about digital experience, it used to be that companies controlled everything with respect to their networks. Applications lived in their data centers, their users sat in their offices. Now your world has dramatically changed. The experience of your customers is dependent on internet service providers, content delivery networks, domain name systems. Your apps and microservices are spread across cloud and internet. So you have a ton of external dependencies which you don't own, which you can't control, and which you can't see with traditional tools. The internet is fragile and there is no SLA for the internet. But with ThousandEyes, you can see into each of your network, including the internet, as your own. As you can probably imagine, the way we build these visualizations is by collecting a ton of time series data and correlating between these different measurements. And when you need to build a dashboard to make sense of a ton of real-time data, that's when Apache Druid becomes a great fit for our use case. Let's see how Apache Druid is helping us to enable customers to visualize the data. The network data is collected by ThousandEyes agents. These agents are deployed in customer network. They generate real-time network metrics like latency, response time, packet loss, throughputs, etc. These metrics are then pushed into as messages into Kafka topic queues. We enrich these messages with product-specific parameters in our enricher service, and then we ingest them into Druid using Imply managed APIs. Let's take an example of a network engineer who is monitoring network traffic for a shopping website on Cyber Monday. He wants to monitor the network metrics in real time. His response to any failure in the network depends on detecting these failures as soon as possible. ThousandEyes dashboard provides means to him to visualize the data collected continuously by our agents. We use Druid to manage the data through Imply managed interfaces. Druid is an ideal database here as it is highly optimized for online analytical processing use cases such as this one. It also offers robust support for data rollups. It provides approximation algorithms on this rolled up data. And it helps us to keep the data size and query performance reasonable. The network engineer who needs to monitor the network data can create dashboards to visualize this network data saved in Druid. He has around 180 metrics, around 50 group bys, and about 50 filters to use. He can use about 12 different charts depending on the nature of the data and what it represents. Some of the examples of the charts are shown in the slide. He can use a map, a pie chart, a time series. This dashboard periodically queries the Druid and displays the pre-aggregated data in real time. Let's get back to our example. as the Cyber Monday sale begins, there mostly will be increase in this network metrics values because of more than usual traffic. Now, if there is any issue with the agent that is collecting this network data, the engineer will start seeing them in the dashboard. This brings us to the problem that required us to upsert data in Druid. So there are additional product specific properties that we add to the messages containing network metrics. We enrich the messages with these additional properties. Some of these properties are not available when the metrics are being collected in agents, but they are guaranteed to be available after some fixed delay. So for our case, this fixed delay is 10 minutes. In the network engineer example, let's say he starts seeing some failure patterns in the data in dashboard. When the network metrics were being captured, if the agent was experiencing any problems like high packet loss, for example, that actually can result in incorrect data. This information about agent having local problems becomes available to us after a few minutes of delay. But the network engineer needs to know that the failures that he's seeing in the data patterns are due to agent's problems. We need to provide a way to identify these data points, but at the same time, we also want to show the best data possible until these points are identified. That means we don't want to buffer the data for 5 to 10 minutes and wait for data points to get tagged with local problems, because that will introduce delay, and like it will introduce delay in all real time data that we show in the dashboard, even in the cases where there are no local problems. If we want, all the data will be delayed by 10 minutes. Because Druid assumes that their data is immutable, we cannot update the data points with local problems in real time, but we cannot afford the delay as well. As a result, we needed a way to update the data, or basically upsert the data with local problems information. There are workaround methods suggested to achieve upserting in Druid for such cases. Let's go over some of the methods that we considered for our case. We will go over upserting data in Druid using batch ingestions, query time aggregation, and deltas with aggregation. The first one is upserts using batch ingestions. This method suggests to rewrite Druid time chunks, that is the Druid time partitions, with the latest data for time chunk. As seen in the image, we can batch ingest the updated data for the whole hour of 11 a.m. to 12 p.m. This assumes that we have all the updated data for that time chunk already available at the time of batch ingestions. This works if we have hourly granularity, but we use one day as segment granularity because we want to make sure we account for any late arriving data. So if we want to use batch ingestions to update the data, then we will have to wait for a day to account for this segment granularity. Even if we reduce the segment granularity so that we can use this method, we will still have to maintain an external system for scheduling the batch ingestions. And the complexity of this scheduling system increases as we add more and more data sources. And in ThousandEyes, we manage around 20 to 25 different data sources. So we couldn't use this method. The second method that we considered is upserting using query time aggregation. So instead of upserting, this method suggests to append all the updates during ingestion. We also need to add an updated timestamp to track the latest version. Once you have this information in Druid, you can then do a select query, which will select rows and get the latest data points using latest by the updated timestamp column. Then you can group the required column like user ID in this example to get the updated value. This pattern is useful in situations where there that many distinct values for the user ID column. If the column has high cardinality, but the performance requirement for these kinds of queries is not very demanding, then this method works. But for us, we needed the queries to be as fast as possible. The third method that we considered was upserts using deltas with aggregation. This method is similar to the one before, but rather than appending and using latest in the query to get the new value, it makes use of aggregations that we use in the query. So as shown in the first table, the data source has a major column points that is aggregated by sum. The old value of points for user ID creepy monkey 1 was 30, and the updated value needs to be 25. So then you would insert a row in Druid with major value as the delta between the old and the new value. So in this case, we will need to insert a row with points value as -5. This would allow you to have correct value of points as 25 for the query when you sum the points grouped by user ID. But unfortunately, this method does not work for aggregations other than sum. And in our case, we use average, max, minimum, quantiles, etc. For showing data in dashboards. As we could not use any of these suggested workarounds, we came up with a new method which we call a delayed enrichment. This method helps us to keep real-time availability of data, which was our goal. It also works for all aggregation types. We can use group bys for any or all the dimensions regardless of their cardinality, and we can still have performant queries. We can remove business logic around properties that need any state to accumulate, like local problems in our case. It also enables us to support a lower granularity rollups, like 1 hour rollup, where we need to enrich data at the time of ingestion because we cannot exclude individual points at query time. Now let's deep dive to understand how delayed enrichment works. Okay. So delayed enrichment method involves storing data in two Kafka topics and two data sources. One of the Kafka topic will have data in it delayed by some fixed period. The data source that pulls data from non-delayed topic will contain the best effort data and will have shorter retention period. The second data source that pulls data from delayed Kafka topic will store the fully enriched data, which means it will have the properties that tag the data points with local problems, basically. As shown in the image, in the enricher service, we enrich the messages from non-enriched topic, which is topic A in this image. We add any product specific properties that are available at this time. We also add a parameter is fully enriched as false into these messages, which indicates these messages might not contain properties that identify local problems in agents. We then ingest these messages into data source A in Druid. We also delay these messages by 10 minutes using Kafka Consumer's pause resume API. By this time, we have the information of local problems in agents. So we enrich these delayed messages with additional properties along with the properties that required some state to accumulate, like local problems. So basically here we add the parameter which will indicate if the agent was having any issues while collecting this data. We also set a parameter is fully enriched as true for these messages and push them into a delayed Kafka topic, which is topic A enriched delayed in the image. Then we ingest these messages from the delayed Kafka topic into a different data source A delayed. We can now use a union query and time interval filter to get the data. So as shown in the screenshot, we query both the data sources using union query, data source A and data source A delayed. For data source A, we use is fully enriched as false, and the time interval filter is just for the first 10 minutes of data. To get the rest of the data, we use the delayed data source, and is fully enriched will be set as true here. And the time interval will be the remaining time period that you want the data for. So at the query time, transparently to the user, we can now exclude local problems by including these additional filters, but without any custom logic around them. And or like, we don't need any custom logic basically to identify them now. So the user can now see data as seamless, and for the first 10 minutes the data might have local problems, but for rest of the period, user guaranteedly sees what if the data has any local problems or not. There are some limitations of the delayed enrichment method. We ingest the data twice and store it. We store it for basically the retention period of data source A, or the 10 minutes in our case. We need to have the updated version of all the data in 10 minutes delay, because once the data is written into the delayed data source, you cannot make any more real-time updates to it. If we still want to update the data, then we have to wait for 1 day, and then we use batch ingestions and update the data for the time chunks that needs update. Yep. So thank you. If you have any questions about delayed enrichment, please email me using this email address.